Good day, students. Today we'll be solving some questions on cyclic quadrilaterals. Last week I explained to you that the opposite angles of a cyclic quadrilateral are supplementary. So we're going to take a few examples today. So look at this circle that you see, is circle PQRS, and this is X, this is Y, this is 35 degrees, this is 50 degrees, and the question says we should find X and Y. How do we do that? Okay, so we are going to look at it. We now, one thing I must say is that a particular question may involve more than one theorem. All right, we may have to use 2, 3, 4, 5 theorems on a particular question, so you don't limit your mind, all right, to one theorem. You need to understand all the theorems. Okay, so if you look at this looks like this is a cyclic quadrilateral. How do I know? The 4 vertices touch the circumference, so this is a cyclic quadrilateral. So if you look at it, x plus 50 are supplementary. X and 50 are supplementary. So solution, I say that x plus 50 equals to 180 degrees. Why? Opposite angles of a what? Cyclic quadrilateral. Okay? Opposite angles of a cyclic quadrilateral. All right, so we have x equals to 180 minus 50. X equals to what? 130 degrees. So we've gotten x. All right, so the next question is, how do we find y? All right, y is not part of the cyclic quadrilateral. Okay, y is, this O is the center of the circle. All right, so this is angle at the center. So that takes us to the second theorem, if I'm right, that I taught you, which states that the angle subtended at the center is twice the angle subtended at any other part of the circumference. So this angle is twice the angle here, if you remember clearly. All right, so we say y equals to 2 times 50. All right, so we put the reason in brackets. Angle at center is 2 times angle at other parts of the circumference. All right, or other parts of the segment. All right, so our y is 2 times 50, which is what? 100 degrees. So that's that about that. Okay, so making use of 2 theorems, we're able to find x and y. Can we continue? All right, so let's look at the next one. Look at this question. All right, we were asked to find x. All right, so you need to first, now this is example 2. You need to first calm down to analyze the question. What does it mean and how do I solve it? Okay, now if you look at it, this is center O. This is center O, and we have a line passing through center O. That tells you that this line is a what? A diameter. That's a diameter. Okay, now in order you see diameter, there is a theorem that should come to your mind. All right, it is a theorem that states that angle formed in a semicircle is 90 degrees. If you remember, angle formed in a semicircle is 90 degrees. So if you look at this diameter, this is 90 degrees. All right, I may not even know what to do yet, but I'm trying to remember everything that I know that is connected to the question. So this is 90 degrees. Okay, now the next thing I want to ask myself is this shape a cyclic quadrilateral? Let's check. 1, 2, 3, 4. So this is a cyclic quadrilateral. Now the question was not labeled, so you can label it. Okay, you can label it. We can label it as A, B, C, D. All right, let's write solution. We started by saying angle ACB is 90 degrees. Why? Angle in a semicircle is 90 degrees. It is important to always give reason to every of your steps in circle geometry. It's very, very important. All right, it's part of the assessment. We are not just saying that, and we don't just want to hear you say ACB is 90 degrees. We want to know why. Why did you say so? Are you assuming? All right. Okay, so now what's the next thing? Since we know that this is a cyclic quadrilateral, it means that the rules of cyclic quadrilaterals apply. and this is angle X. All right, and we are looking for this side. We are looking for this side. Sorry about that. We know we are looking for angle X. All right, and this is another angle, and we know that these two angles are opposite. That means they are supplementary. All right, they are supplementary. Now I want to add something to this question. Let's assume that we are also supposed to find y. All right, we are supposed to find y. I'm adding to this question now. So we're looking for angle X, and we know this angle. We can get this angle here. We know that this plus this will give us 180 degrees. If we can get this angle, we can get this angle because they are opposites. Are you getting what I'm trying to say? All right, I hope I'm not confusing you. This angle and this angle, they are opposite. So adding them together will give you 180. So how do we get this angle that is here? Now, remember that this is a triangle. This is a triangle. All right, so we say consider triangle ABC. Triangle ABC, we are considering it. Remember that this is 90, this is 52. We can get this place. How do we get it? Remember, sum of angles in the triangle is what? 180. So we say that 52 plus 90, pay attention, all right, plus 90 plus angle ABC. That's the angle here. Angle ABC is 180 degrees. All right, 52 plus 90 plus angle ABC is 90 degrees. Okay, now this is angle ABC. ABC, that's the angle here. Okay, that's the way we label the angles. Okay, so pay attention. We are getting it. So we can say 52 plus 90 is 142, right? Plus, we have not put reason here. Let's come back here. Why? Angles in a triangle. That's the reason. Angles in a triangle. All right, so we say 142 plus ABC equals to 180 degrees. ABC equals to 180 degrees minus 142 degrees. That is equals to what? 38. So this is 38 degrees. Do you understand? This place is 38 degrees. Okay, so this plus this plus this equals to 180. That's how we got this place. But remember we are looking for x. So we can say x plus 38 gives us 180. Why? All right, x plus 38 equals to 180. Why? Opposite angles in a cyclic quadrilateral are supplementary. Opposite angles in a cyclic quadrilateral are supplementary. So we have x equals to 180 minus 38. X equals to what? 142. All right, so our x is 142. Okay, that's our x. However, I added a question to it. I said we should find this angle, this side y. We should find this side y. All right, so the question is, what is Mr. Timothy trying to bring out from this question? What are we trying to bring out? Now, remember that we have a sign here. What does this sign here mean? It means this side and this side, they are equal. So that tells you that this triangle is isosceles. This triangle is isosceles. So let me write that. So triangle ADC is isosceles. Just follow me, you're going to get it. All right, so this is isosceles. So, and what is the rule of isosceles? The rule of isosceles says two sides are equal, base angles are equal. So that means this is y, this angle too is same thing as the angle here. This is also y. That's what it means. Are you getting? If this is 10, this is 10. If this is 20, this is 20. All right, the base angles are equal. Are you getting what I'm saying? All right, the base angles are the angles formed by the equal sides. All right, with the base. All right, this is the base. Okay, so if this is y, this is y. Pay attention to this. So we can say that y plus x equals to 180. Remember, angles in a triangle. All right, what's our x? Our x is 142. If you remember, y plus 142 equals to 180. Y plus y is 2y plus 142 equals to 180. This is a simple equation. 2y equals to 180 minus 142. 2y equals to what? 38. Divide both sides by 2. Y equals to 19 degrees. So we have gotten our x and our y. All right. So there are still so many questions I would like to solve with us, which I will still solve as time goes on. Thank you very much. Have a beautiful day. Please ensure you do my classwork. Okay?